In this video I will show how to make a hearing test with a microbit. The test can show how high a tone one can hear. The ability to hear high tones decreases with age. Tones above 20,000 Hz cannot be heard by humans. They are called ultrasound. See my video about this. P0 and ground on the microbit are connected to a buzzer. A headphone can also be used. When I press button A, the frequency rises up to 18,000 Hz, after which it goes down again to 1,000 Hz. In the program, we will use these two blocks. In order to understand their behavior, we must first look at the subject's frequency, period, and duty cycle. Frequency is the number of periods in 1 second. A period is the total length of mark and space. Frequency is measured in the Hertz unit. Here are some examples of different frequencies. We will now calculate how long one period takes when the frequency is 2000 Hz. 2000 periods take 1 second. Therefore, one period takes 1/2000th of a second. If we measure in milliseconds, we must multiply by 1000 and we get this fraction. But we would like to have the number in microseconds. Therefore, we multiply with 1000 once again, and we get this fraction. When we have reduced the fraction, we see that each period takes 500 microseconds when the frequency is 2000 Hz. We will study it more closely in a spreadsheet. Here I have entered the desired frequencies, and in column A I have given them a number from 0 to 9. Now I mark column C and choose to have 0 decimal places. To calculate the time period in microseconds, I make a formula where I divide 1 by the frequency, which is in cell B4, and multiply by 1 followed by 6 zeros. Finally, I copy the formula into the cells below. In the program, the numbers we have found must be entered into an array. Here each number gets an index value. So when I ask for the number at index 1, I get 500. The microbit must feed the buzzer with square waves. It works best if they have a duty cycle of 50%. The highest number we can write to P0 is 1023. Half of this is 512. So we can write that number in the block and we get a duty cycle of 50%. The period must be read from our array. The actual number must be found from the value that the variable press has. That is the variable that we influence when we press button A. From this piece of program you can see how it works. I will now show how to make the program. I start with the array and fill in the numbers from the spreadsheet. Then I make a variable called press and give it the value 0. Now we must program the part that makes the square waves. The blocks are located in pins. I program the analog set time to get the numbers from the array. And I make a duty cycle of 50% by writing 512 in analog write. I make the program show the value of press. Now we need to program button A to change the value of press. Here I only use single-digit numbers, so you do not have to wait for what the microbit is showing. Now we can download the program to the microbit and connect the buzzer. When I connect an oscilloscope, you can see that the duty cycle is the desired 50%, and that the square waves become slimmer and slimmer the higher the frequency becomes. Here is a different frequency range you might want to try. With this, you can more precisely determine when different people can no longer hear the high tones.